All right, guys, let's talk about finding slope of a line. I've got a few examples here. Let's dig right in. All right, so let's slide on down here. Usually when we have some type of line, we'll have a coordinate plane background behind it, but not always. I mean, we could just have a line, but we'd need to know some information about the amount of left or right movement of that line relative to its up or down movement. And an easy way we usually depict that is to have a coordinate plane overlaid on the line. So let's just go that route for what we're going to be working with today. So I already got a line drawn here. I don't really have any numbers put on our coordinate plane, which is okay. We'll just assume it's everything's a 1-to-1 ratio. We're going by ones. Okay, so a lot of people struggle with finding the slope of a line when it's just given a line, right? There's no points really shown. So the best way I think to go about this is to actually go down through your line, scan down through your line, and see if you can find any nice points that are on your line. Okay, so if we scan down through here, like I noticed that's a good intersection point right there. So I'm gonna go ahead and call that a nice point. There's another nice point, right? And there's probably some other ones along here, but all you need is two. Okay, so find two nice points. Now what I like to do is I like to always draw a right triangle between those two nice points. Now you could either draw your right triangle like this, or you could draw your right triangle like this. It doesn't matter, either way. So I'll just go this way for now. Okay, draw your right triangle. There's your right angle right there. Okay, and make sure you go count. Okay, so let's go count this is called your rise, your vertical distance between two known points. And this is called your run, your horizontal distance between two known points. So let's go ahead and count that. So from here to here's 1, and then 2, and then 3. So our rise is 3. Our run is going to be 1, 2, 3, 4. And man, we're almost there, guys. So our slope, okay, which a lot of times in algebra they call that little m. Okay, little m is slope a lot of times. M equals rise over run. You've probably heard that before, right? So rise over run. So you just count up the rise between two known points, count up your run between two known points, right? We could have also done it this way, right? There's your right angle, right? So the same thing, our rise is 3 and our run is 4. There we go. So same thing, rise over run. So we're over here, rise, up and down distance over run, okay? Rise over run. So little m, slope, is going to equal rise, which is 3, over 4, which is our run, rise over run. Now, one other thing to remember here is slopes can be positive and slopes can be negative. Now, the way I like to remember it is a line that goes up and to the right is always a positive sloped line, and a line that goes up and to the left is always a negative sloped line. I just remember it that way. There's some other ways to remember it, but I think that's probably the easiest, shortest, sweetest way to remember it. Okay, so this line is obviously going up and to the right, so it's a positive slope line. That's got a positive, right? Any number that you look to the left and if it doesn't have a sign, it's automatically assumed that it's positive. We don't need to put a positive there, right? So this means positive 3/4 slope, or you could say that it's a positive 0.75 slope, or you could also say, you could turn that into a percentage, right? You could say that this line has a 75% slope. Either way, right? So those are really all three good versions of an answer here for the slope of a line. Let's go ahead and do one. Let's do one like this. Okay, let's do this one real quick. All right, so we got a line drawn here. Okay, let's scan down through that line and pick two nice points. So if we scan down through here, that's a nice point, right? There's a nice point. There's a nice point, right? We could have lots of nice points. All you need is two. Pick any two. I could pick this one and this one, draw my right triangle. I could pick this one and this one, draw a right triangle. I could pick this one and this one. Doesn't matter if you do it right. Okay, so maybe we'll pick the big one this time. Let's say we decide to draw a right triangle between these two nice points. That's fine. right triangle. All right, let's go ahead and count up our rise and our run. So our rise is going to be 1, 2, 3, 4, 5, 6, 7, 8 increments. And our run is going to be 1, 2, 3, 4 increments. Let's go ahead and build our slope out. Okay, so slope, little m, is rise 8 over run 4. And like we just got done talking about, this line is going up and to the left, right? So that's a negative slope line. Lines that go up and to the right are positive slope lines. So this is a negative slope, so all we need to do is slap a negative on this fraction. And it's best to always simplify if we can. So negative 8 divided by positive 4 is negative 2. So there we go. We could say the slope's negative 2. We could also say the slope is negative 2 over 1 if we wanted to leave it in fraction form, or we could turn that into a percent, and we could say that this has a negative 200% slope. So there's our 3 different versions of the same correct answer right there. So there you go, guys. Did a couple of examples of finding slope on a coordinate plane, how to utilize rise over run, and how to tell if we got a positive or negative sloped line. Hope that helps.